All right. So a system of inequalities, the easiest way to solve it is graphing because of how many answers you could possibly have. There could be lots of them, they could overlap, or maybe they don't have any, and we're looking for combinations of x and y that are going to make the original true. So if you see here, this is a system of inequalities because we don't see an equal sign necessarily. Okay, there is some kind of inequality, so maybe greater than, less than, or a variety of other things could be. So what I look at it, and the way I start these is let's just turn them into equals. Okay, so we'll do that, and then this one here as well. Now I would strongly recommend that as you start this one you use pencil, and I can get the colored pencils out if you believe those will be helpful, and sometimes they are when you have systems of inequalities. But right now you should know these graphs should be very familiar to you. They are lines. All right? So just kind of figure out, maybe get some points on there as to where those lines would go. So take a minute or two to do that. So with the time you've had with lines, you should be pretty good at that. You just got to get some points because you should know that this is a line. And so if we put 0 in for x, for example, in this first one, what's our result? 5. So 0, 5 is a point. And then you probably get a few more. So maybe 1, 6, right? 2, 7. You get the idea. So now what we have to decide is, are those points that I just chose, 0, 5, 1, 6, and 2, 7, do they make the original one up here, do they make it true? For example, if I put 0 in here and 5 there, because that's the point I chose, right? Does it make the original true? Is 5 greater than, well, this is 0 plus 5, is it greater than 5? No, so it doesn't even make that true. So is it part of the solution? No. But it is what I like to call a boundary line. Your solutions are really close to that line, on one side or the other. We don't know which side yet. But it's not on that line, but we still use it as a boundary line. And to show in our graph that it's not part of the solution, we make it a dashed line. Because the points that make up that line do not make that inequality true. Now I know a lot of you just remember that if the little equal to thing is not on there, you just make it dashed. Okay, but this is why. It's because it doesn't, those points don't actually make it true. So how about this other one? If we pick these points, maybe you chose, what, 0, -2, right? And maybe 1, -1, maybe 2, 0. Maybe those are some of the points you chose. Do those 3 points make that true? No, none of those points make that one true. Okay? But we could graph those easy enough, right? They're right there. Okay. Well, those are supposed to be parallel. They don't really look like it, but they're supposed to be. Okay. So those are boundary lines. So right now, on the board, how many combinations of x and y do I have graphed that make both of these inequalities true? They have to make both of them true. Do I have any points right now that make both of them true? And technically, right now, how many combinations of x, y do I really have graphed? If I'm trying to, right now I don't have any in reality, because I'm just putting boundary lines up. So now what we have to do is find out, well, where are the solutions? And we look at them individually. So let's go back to this one. We know that it's this line, right? So let's pick something either above or below that line and see if it makes the inequality true. What's probably a really good choice? 0, 0, right? We're going to test that point right there with reference to that line. And we're going to see, is that where the solutions reside or not? So we put 0 in there. So I'll write it down here. 0 greater than 0 plus 5. So in other words, 0 is greater than 5. Is that true? No. So with respect to this line, 0, 0 really is not where the solutions are. So if they're not below the line, they must be above the line. So any point up here makes what true? It makes this first inequality true. Does it necessarily make them both true at the same time? No, not yet. It might, right? But that's for us to figure out. So far we've got the first inequality. So now let's work with the second inequality. Can we test 0, 0 again with the second inequality? Yeah, because it's not on the line, right? So if it's not on the line, we're basically testing, if we're testing this line over here, we're testing above it. So we try 0, 0. So we got 0 less than 0 minus 2 is 0 less than negative 2. No, that's not true. So again, with reference to this line, 0, 0 does not make that inequality true either. So if it's not above that line, it must be below. So the blue shading shows you where all the answers are for that inequality. The green shading shows you where all those answers for that one are. I want to know where all the points are that work for both of them. So where are they? Yeah, there aren't any. There is no combination of x and y that will work in both of those. So really, after all this work, what's the answer to this system of inequalities is, yeah, there's no solution. There is none that it goes, and they're in both. So what we're looking for again is where they overlap. Okay, for those points of x and y. Okay. Any questions on that first one? All right. So let's try another one. Solve the system of inequalities. Then name the coordinates of the vertices of the polygonal convex set. I'll show you what that means when we get there. So what was my first step again? Basic graph what? The border or the boundary line. And how do we find that? By simply turning it into equals, correct? X equals 0. That is one of the special lines that you need to remember what that looks like. X equals a number, or basically all the places that x equals 0. Could you come up with a bunch of ordered pairs? 0, comma, anything, right? 0, comma 1. Does that make this true? Does x equal 0? How about 0, comma 2? Is x 0? Sure, 0, comma 4. You get the idea. So 0, 1, 0, 2, 0, 4. So we get an idea of where that line is, correct? Do these points make the original true? Yeah, because if I put 0 in, I can only put 0 in for x. There's no y to put 1 in for, is there? So you don't put it in. Is 0 greater than or equal to 0? It is. Well, now what do you do then? That line actually also represents possible solutions. You make the line solid. Maybe. There it is. Okay, so that's that line. So maybe we should you want to do the shading as we go this time, or make the lines? What do you want to do? Make the lines first, then shade? Okay, you can do it either strategy. So let's go with this. So now we're going to make this a boundary line, so it's y equals 0. So again, if you forgot, you just actually make some points. So like 1, 0, negative 2, 0, negative 3, 0. You get the idea. So 1, 0, negative 2, 0, negative 3, 0. So again, do these points make that true? They do. They are actually part of the solution. So this time the boundary, at least a couple of the boundary lines, are part of the solution. Okay? Yes, we have a question. No, x equals a number is your vertical line. Y equals a number is your horizontal line. Exactly, the x-axis, exactly. Yeah, that's why people get it confused. And that's why I give you a strategy here of just picking points that make it true and then graph them. That's probably the easiest way to do that. Okay. Now we've got one more. X plus y is less than or equal to 5. So there we go, x plus y equals 5. Is this going to be linear? It could be a line? Yeah. So our job is to find some points that make that happen. So how about maybe 5, 0, right? 0, 5, 2, 3, sure, right? Lots of them, right? So 5, 0, where's that? Oh, there it is. 0, 5, 2, 3. How about these 3 points? Do they make the inequality? Yeah, you can see it, I know. Does it make the inequality true? Yeah, because it's equal to, right? 5 plus 0 less than or equal to. 0 plus 5 less than or equal to. 2 plus 3 less than, they're all equal to, right? And so solid once again. Now here's where people I know that come in from other classes just assume the shading is in the triangle that you see. It does not have to be. Okay? It could be above the triangle, it could be below, it could be just about anywhere. Really, now don't write this in yet, but the shading could be down here. Okay, don't assume that all your shading overlaps in the triangle. I'm pretty sure it does in this case, but let's find out if we can figure out how to decide that. So for this first one, you have to remember which line it is first off. It is that line, correct? So we need to test a point. Can I try 0, 0 as a test point this time? No, I want to find out if the solutions are to the right of that line or to the left, and 0, 0 is on that line. So that's not right or left, so you just have to pick something else. 1, 1. So again, we're going to test this point then with reference to that line. So 1, 1, but I can't put y in, so you don't. Okay, so you put 1 greater than or equal to 0. Again, we're testing 1, 1 right now. Is that true? It is. So based on just this very first line, all the answers are to the right of it, correct? So now we've got y equals 0. We'll do that in green to try and color code things for you here a little bit. Y equals 0. So again, can we choose 1, 1 again? Could we try 0, 0 this time? No, you can't try that one because it's actually on that line. But we can try 1, 1 again, so let's do that. So again, 1, 1, but I only have the y value, so that's all you can put in. So 1 is greater than or equal to 0. Hey, that's true again. So now, so far, what would be a good description of where we have shaded together? Quadrant 1, correct? So now, we're narrowed it down. It's either going to be in this triangle or kind of out in this region, kind of to the top right. So now we have to test a point for this third line. Can I once again choose 1, 1 as my test point? Sure, it's not on the line, so let's do that. So now it's 1 plus 1 less than or equal to 5. So in other words, 2 less than or equal to 5. We're testing to see if that's where they are. That works. So I'm actually going to shade perhaps in blue here. Is there any location where all 3 of them shaded? And it is the triangle. Yep. So question's how we found that. So what that really means is I can take any point from in here, any of them, or even on these lines, right, because they're part of the solution set. Any of them will make all 3 of these correct at the same time. Not just 1, not 2, all 3 of them at the same time. So any questions on just that part? So now, a lot of times when you do this, you are going to find a convex polygon. Do we have a convex polygon shaded in? Yeah, it's a triangle. And I would like the vertices of it. So some of them are very easy to see. For example, this one is 0, 0. And we've got this one up here, which is 0, 5, right? And then this one over here, which is 5, 0. Okay, those are the vertices of the polygonal convex set. Those are going to be very important points here in a little bit when we do another problem. Any questions so far? Why would we find the vertices? Because those are going to be where we can maximize or minimize certain things. Have to be at the vertices, which are the extremes. They are the extreme combinations of x and y. Okay. So here we go. I'm going to stop the recording here, or actually pause it, and I would like you to try and graph these lines. And the lines that I'm referring to are here, 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 and here. Okay. The one circle in blue, notice we've got this one in green that I just put a box around. That is the max-min function. That is not one that you graph. Okay? You only graph the 4 that I've circled in blue. So try that now. I'll come around and see how you're doing. Again, if you're listening to the recording, actually please pause it. All right. Now, some of you came across a problem that does happen to a good number of students, and that is, boy, how do you tell where the stuff is? After you start shading, it all looks the same, right? And so a lot of times what I like to do with these are the special lines, but let's face it, we should know pretty well at this level, we should know where those leave us. So do we really have to shade for those? Okay. I'm hoping that you don't necessarily have to shade for those. Because really, let's face it, it's the same. In this case, it's the same as the last one. It leaves us in the first quadrant. Because that's where both x and y are positive. So now that we know we're in the first quadrant, we don't have to worry about 2, 3, or 4. So now let's get some of these lines. So for this first one here, maybe we'll do that one in blue. We've got what? 2, 0 as a point, 0, 4, and 1, 2. Let's just pick in some quick points. Now, do those points actually make the inequality true? They do. Okay, so the line itself is part of our solution. So I got to go to 0, 1, 2, 3, 4. There it is. So now, it's up to you if you want to shade at this point. Can I choose 0, 0 to check 2x plus y less than or equal to 4? Yes, I can, because it's not on that line. Is it on the other ones? Yes, but that's not the one I'm testing right now. So if we try that one, try 0, 0. Well, 2 times 0 is 0, plus 0 less than or equal to 4. Is that true? It is. So from that line, it basically shades below. So far, I'm basically sitting, and I'm going to erase this in a second, I'm basically sitting in that triangle so far, correct? Unfortunately, this time we have another line that cuts through and tries to eliminate some of those options. Actually, I think I'm going to leave that on there. That might be helpful. So we try some points for this last one, and we'll do that maybe in black will work. So we got 1, 2, 0, 3, 3, 0. Okay. So those points actually make it true, so we'll go over there. So now, with that one, can I once again choose 0, 0 as a point to find out where the answers are? Above or below? I can. So we've got 0 plus 0 less than or equal to 3. Well, that's also true. So from that one, basically, do you see how this little region right here gets eliminated as a possibility because it's above that line? Okay. So where they all shade together, that quadrilateral. That's where they shade together. Because it's below this line and below that line and above the other two. Above that one, above that one. So that's where they all go together. Okay. Any questions on that? And one way that can help you is to actually use the colored pencils. I know you don't want to, but it is a good way to help you out to have it somewhat color-coded. So now we got to get the vertices. How about this one, this big one right here? Where am I going to write? We'll write them up here. 0, 0. All right, this one was from which line? From the last one, correct? So that point is 0, 3. This point over here is from the second to last line, so that's 2, 0. How about this one that's kind of out there? It looks as though it's 1, 2, correct? Is there any way that I could check to see if it's 1, 2? What do you mean? Yeah, it's where those two lines intersect. So I could actually go up here and do the algebra and find out where those two intersect, or I was fairly clever when I chose my points. Okay, it actually is on both of them. All right, so that's something you could choose. Though, is actually just substitute it in, like somebody said, and see if it actually works in both. If not, you may have to do elimination or substitution to find out where they intersect. Okay, because I do believe there's one on one of your assignments that does not intersect at a very nice location. Okay. Yep, just make them equals, and then do either elimination or substitution to find out where they are equal. Yep. All right, so now that we have our points, is everybody clear how to get to the point we're at right now? Well, now we're going to finish the problem. Now we're going to take each one of those ordered pairs and put it in here. You notice that's f of x, y. Okay, that's a little bit new for you. We're going to try and maximize and minimize it. So we're going to find the maximum and minimum value. So we have to find f of 0, 0. We have to find f of 0, 3, f of 2, 0, so that's why you notice you were given pretty much the whole back half of the notes for this particular problem. So f of 0, 0. Is everybody ready? So that means you basically put 0 there, and then 2 times 0, and then plus 1. So it's 0 plus If I put 0 in there, times 2 is just 0, right? Plus 1, so in other words, it equals 1. So f of 0, 0 is 1. So now let's do 0, 3. So wherever I see an x, I'm going to put 0. Wherever I see a y, I'll put 3. So 0, and then plus 2 times 3, plus 1. So it's 0, plus 6, plus 1. Any question where the 6 came from? Everybody good? Let me know if I'm going too fast. F of 2, 0. So 2 plus 2 times 0 is 0, plus 1, so 2 plus 0 plus 1 is 3. And then 1 comma 2. 1 plus 2 times 2, which is 4, plus 1, so 1 plus 4 plus 1 is 6. If we were to find the combination that maximizes and minimizes, and here how I would strongly recommend that you write it, something like the max, well, it's what? Max is 7 at, ooh, that's a good one, at 0, 3. And the min is 1 at 0, 0. Not only what the min and max is, but also where it occurs are both important information. Okay. Right now, the question is, what do those numbers mean? Right now, those numbers don't mean anything to you. Once we associate this to a story problem, they will. But I couldn't possibly give you the story problems right away because it would have been overwhelming. We're working towards what's called linear programming. And then those numbers will mean something. Well, computers do this a lot for businesses. Well, you realize when they do it for a computer, they have 100 equations instead of 4. Pretty sure doing 4 by hand is quicker than typing in 100 and having the computer do it. Are there any questions of the process that we went through today on any of them?